My name is Calvin Wara. I work at CMRD as a thematic lead on water and hydroclimatic disaster. Within the thematic area, we work in Kenya, Uganda, and Tanzania. In Kenya, we are mostly dealing with two service areas, that is stream flow focusing, stream flow monitoring and focusing, and water quality mapping. Within the area of the stream flow monitoring and focusing, we are using hydrological model to be able to predict predict and monitor the stream flow, which eventually is muchly applicable in water resources management, water allocation, and planning purposes. In Tanzania, we are running an hydrological model called variable infiltration capacity module, which is a fully distributed hydrological model. And the purpose of running the model is to be able to characterize the hydrological behavior within the two basins, that is the Wami-Ruvi basin and Rufiji basin. The two basins more experience similar challenges that string from climate variability, water scarcity, drought, and flood. So we are looking at the possibility of using the model to be able to characterize the hydrological conditions, and then on the basis of the model output, we'll be able to generate daily stream flow that more cover the part of the data scarcity within the region, and also the possibility of using the hydrological model for prediction or having an outlook, hydrological outlook, or the behavior of the system in the future, near future, and more far future. And in September, we conducted a training just simply to build the capacity within the area that we're working with. And in this particular area, we're working with the Ministry of Water. We are working with the basin water boards of the two basins. We are working with other private sectors that operates within the basins. A typical example is TENESCO, which mostly deals with the hydropower generation. And we also work with the University of Sokoine, with various capacity within that institutions, taking advantage of various capacity within that institution. We also work with the Ministry of Agriculture, Department of Irrigations, and also the NEMCA. The training that we conducted in September was more to build the capacity of the ministry staff or the basin officers with regards to the application of a hydrological model in solving certain day-to-day operations that is being conducted in the basin. So in the long run and short end of it is to have a platform that would enable to address the issue of data scarcity within the region, and also be able to feed into the basin water planning. And these are typical examples that provide the information to the basin operations that involves the data collections. It involves the applications and allocations of water availability. It involves the issuance of permit and dealing with the issues of the water right within the basin. Now, the benefits of having such a model is to enable the basin operations to conduct their day-to-day operation in a very easier or in a very transparent and a very easy manner. This is being done in the precepts of the needs assessment that was conducted sometimes in 2017-2018 that informed the formulations of this particular work. And in the training, it became very clear that indeed using the VIC model will be very important, because one of the output of the VIC model will be the stream flow, or is the stream flow, is the surface, which is the surface runoff, the soil moisture, evapotranspiration. So all these informations are normally being gathered, but we are looking at a situation in which these informations can be retrieved from an e-platform or a web platform like Tethys that would inform certain decisions that are being made in the basin. And the decision is around data collection, decision is around water availability assessment, the decision is around the allocation of the amount of water available to the various competing interests within the basin. In other regions like Uganda, we are running an EF5 models that is both in Uganda and Kenya to build the capacity of various government agencies to deal with the issues of the flood in terms of its prediction and early warning system. And in those particular areas, we have done quite a bit of some work in terms of building the capacity of the institution to understand how the model works and in what framework and what kind of information that can come to out of the model and will be applicable in the day-to-day operation. One underpinning thing that you find within this area of operation is that all revolves around the application of Earth observation to build a model and be informed of certain decision. And in Kenya, we have planned another capacity building with the EF5, that more of setting up a server that would be used to retrieve this information, disseminate it to various stakeholders that needs it in order to make certain day-to-day decisions within those basins. In all these applications is based on being able to get the satellite, be able to use Earth observation like satellite data to run a agricultural model. And in all this is just to build the capacity of the regional states, the contracting regional states members for the RCMRD or within the hub to be able to deal with the water stresses challenges or water and hydroclimatic disaster. These challenges are often reactionary in a way when it happened, but immediately after they happen, for example, the issue of flood and drought, when immediately after they happen, the memory fades, and so the institutional response to them falls. That is what we would like to run away from, build the capacity in such a way that when the disaster strike, especially agricultural extremes, then the possibility to respond to this disaster or mitigate this disaster is enshrined in the agency that are tasked or mandated to deal with this in this sector.
My name is Rosemary Maskini, hydrologist from Wamiruvu Basin, and I'm particularly doing water resource assessment and monitoring the basin, where we collect data on rainfall, temperature, land cover, land use, discharge, flows for decision making on water resources. Actually, it's for water allocation.
Great. Yeah. Can you tell us briefly how beneficial this training is to you and to the people that you work with?
Yeah, the training was very crucial to my career in the institution that I'm working with, because we usually have a lot of challenges during decision making, and this is actually the flow availability in most of the streams. So we cannot gauge every station, but in terms of decision making, you are actually doing in the whole basin. Each stream can be a water allocation. So with this training in particular, it can equip me in allocating water into engaged streams through modeling, which will actually help in the decision making. Yeah, I have seen this training, the model in perspective, VIC model, very useful to our daily activities. Though there are some stuff that we really need to dig on to be able to really implement or apply the model, like the coding. You know, most of the people, including me and my fellow, we are not like the good programmers. So in this case, to really apply this, we need more training or more capacity on the coding. And if possible, if the VIC can have an interface, mostly user-friendly, where code is behind the screen, it will be best, really best for us.
My name is Asha Mohammed. I work for Waridi project as the Wamiruvu Basin Support Specialist, and now as the Rufiji and Wamiruvu Coordinator as well. So my day-to-day activities as the Basin Water Boards Coordinator is to see what are the Basin Water Boards needs and what are the Waridi's plans regarding the support that is geared towards improving the basin water boards and the Ministry of Water at large. So we, as Waridi project and as the Basin Water Board coordinator, I look at the governance of water resources management and mostly the institution part. We are supporting the data management and improvement of decision making through having the best data, and also in the climate change part, we've been looking at different at how the basins are vulnerable, and now we are moving towards improving the data and having the basin working with more improved enhanced data, merging the ground data and the earth observed data. And during this week we were learning about the VIC model, which is helping the basin water boards come up with discharge data, which is model the discharge, and at the end of the day decide based on informed information, improved informed information. So we've been doing support in equipments and then database, and now we are linking that the data that has been collected initially, and we had database that had improved that data which was collected, and we are now moving that data into a model which will give us now what will be passing by where at what time, say. So I see that as a step, and very important as a coordinator to be part of it, to know that these are the areas that mostly had issues, and now we are forging those collaborations, and we are capacitating the staff and realizing areas maybe that need more capacity building. And
my name is Paul Ruben from Sokoine University of Agriculture. I'm working there as a research technologist. Being there, we conduct different activities, the major role being teaching, but also conducting research. Currently, we have been conducting a research on remote sensing application in agriculture, especially in water and nitrogen management. So we have been ending there, and we had no opportunity of getting more e-resources which are relevant in water management, as we were using unmanned aerial vehicles, which generally generates data from a bit of medium-scale agriculture. But employing those information together with the e-resources, which we have been trained in this training, gives us much familiarity to available resources, and hence to do more modeling in the future. We are training engineering students who in the future might be employed in the Ministry of Agriculture, but also in the Ministry of Water Resources Management. So being there, when they get time to work with the water resources, in water resources engineering, our students will be much capable on working in those areas. Yeah, among of the roles at the university is training, and we do training on irrigation engineers who in the future can work as irrigation engineers, but also as water resources engineers. So VIC training is a hydrological modeling. It will improve my career, and then I'll use this knowledge to capacitate those engineers that in future the model will be at their fingertips to be applied in their area of employment or wherever they will be doing their career in future. But also in research, I see a big opportunity in future, as now we have reached to the point of using only remote sensing information in conducting research in different areas of water and nitrogen management. But that is being conducted under several crops, in various crops, so that we can have a guideline on, for instance, if we can talk about vegetation indices on different in different levels of water stress. For instance, if we speak on horticultural crops are really consuming a huge amount of water, but if we can link the knowledge of hydrology, especially Vic modeling, and the water use in farming, so that can give us a message on how we can improve water use efficiency, so as to make sure that the water resources which is available can be sustainably used.